We now move on to the division of polynomials. And before we go into that, we just want to refresh your memory on how to do long division, because this is what you use to divide polynomials. And long division, we have an example right here where 1205 is divided by 8. And I'll guide you through this just as a refresher. So to do long division, you first check, does 8 divide the first number? And it doesn't here. So you move on to the second number together. So does 8 divide 12? Even with a remainder, it's fine, right? And does 8 divide 12? Yes, it goes into 12 once. And you would subtract 8 and you get a remainder of 4. Then you bring down your 0. And does 8 divide 40? Yes, it does. How many times? 5 times. And your remainder is 0 from that. And then you bring down 5. Does 8 divide 5 here? Does 8 divide 5? No, it doesn't. But we can then move it further on. So if we add a decimal point, we can add another 0 right here. And does 8 go into 50? Yes, it does. How many times? 6 times. So you subtract 48 here, you get remainder of 2. And then you can keep on adding a 0 until you're done with your remainders. So you add a 0, does 8 go into 20? It goes into 20 twice. Subtract 16, the remainder of 4, add your 0 again. Does 8 go into 40? Yes, it does without a remainder after dividing it by 5. So minus 40, you get a remainder of 0. That means 1205 divided by 8 is going to be 150.625. Next, this is now using the algebraic long division without a remainder. There's not going to be a remainder in this division. And doing this is quite similar to the other one, but you are mainly dealing with the variable term that you have. So you will take your first term and see if it can be divided by this variable, and yes, it can. It's going to give you x squared. So you write your x squared on top, and then you take this x squared and multiply it by x, you get x cubed, and take this x squared multiplied by negative 2 as well, you get negative 2x squared. Then you will subtract it, obviously, to find your remainder. X cubed and x cubed cancel each other out, and you remain with 4x squared. Then you bring down your negative 11x minus 11x, and you check if x goes into 4x squared. And yes, it does. How many times? 4x, right? And then you take that 4x, and then you take that 4x and multiply by x and multiply by negative 2. 4x times x is going to be 4x squared. 4x times negative 2 is going to be negative 8x. And you want to find your remainder again, so you subtract by this entire thing. 4x squared minus 4x squared is just going to be nothing. Negative 11x minus 8x is going to be negative 3x as your remainder. Then you bring down your last value, which is plus 6. And you check again. Does x go into negative 3x? Yes, it does. How many times? Negative 3 times. And then you take your negative 3 multiplied by x, you get negative 3x. And you take your negative 3 multiplied by negative 2, which is going to be plus 6. And you can subtract that again to get your remainder, which is going to be 0. That means if you take x cubed plus 2x squared minus 11x plus 6, and you divide it by x minus 2, you will get x squared plus 4x minus 3. And you can write this another way where if you take x minus 2 and multiply it by x squared plus 4x minus 3, you will get x cubed plus 2x squared minus 11x plus 6. Next up is algebraic long division with the remainder. Now, I just want to touch upon one thing before I go into this. And suppose I was to divide 8 by 5, okay? And the way I would do it, long division, I do 5 divided by 8 divided by 5. 5 goes into 8 one time, minus 5, you get your remainder as 3. Then the way I would write it is in a mixed fraction, where I would write 1 and 3 over 5. This is literally the same as I have one item and I add 3/5 of an item to it, okay? The thing I want you to notice is that the remainder, okay, is added as a fraction of your divisor. So we're going to do that here. We're going to see how it works. So if you notice here, the original equation was 2x cubed minus x plus 52, but we add the x squared term to make it easier for us to divide. So again, the same thing, x goes into 2x cubed how many times? 2x squared times. Then you multiply each of them by 2x squared. You get 2x cubed and 6x squared. Subtract then. These cancel out. 0 minus 6x squared is just negative 6x squared. Then you bring down your negative x. And how many times does x go into negative 6x squared? It goes into it negative 6x times. The negative 6x times x is negative 6x squared. And negative 6x times 3 is negative 18x. And you subtract that to get your remainder. This one's cancel out. Negative x minus 18x is negative x plus 18x, which is just 17x. Then you bring down 52. And you want to divide this again. So x goes into 17x how many times? It goes 17 times. And then 17 times x is 17x. And 17 times 3 is just 51. So you'll add 51. Subtract here again. You end up getting your remainder as, obviously this cancel out, 52 minus 51 is 1. So your remainder is 1. And what has happened here is that 2x cubed minus x plus 52 divided by x plus 3 will give you 2x squared minus 6x plus 17 plus your remainder. Now remember how we wrote a remainder here. We wrote a remainder as a fraction of your divisor. So plus 1 over x plus 3. And so basically if you multiply by x plus 3 on both sides, you will get your 2x cubed minus x plus 52 equals to x plus 3 times your 2x squared minus 6x plus 17. And then here the x plus 3 would cancel out, then you would have a plus 1 at the end. Because if you multiply these two, you will get plus 51. So you'll have to add your 1 at the end to get your plus 52. And that's how long division with a remainder works. Next up, we look at a different way of solving a division. Okay, so the first one was using long division. The second one is using synthetic division. And this is a special case where your coefficient of your x cubed is 1. And the steps for this are given. So suppose you were to divide x cubed plus 2x squared minus 11x plus 6 by x minus 2. The first step you would do is you take your divisor, the thing you are dividing, and you equate it to 0. So solve that. X minus 2 equals 0, you get x equals 2. Then you want to write this answer outside of the L shape. What the L shape is, I'll explain right now. Then you go down to your coefficients and write your coefficients as they are. So you have 1, you have 2, you have negative 11, you have 6. Obviously, this is in descending order of the powers, right? So again, if you have x cubed and then 11x, then you would add a 0 before your 11, okay? And you draw your L shape right here, and you have your number that you got initially to be outside. What you do after that is in step 4. The first number inside the box, which is 1, you write it directly downwards, 1. And then what happens is this number goes up here and you multiply it with the number outside. So this number is 1 multiplied by 2, which will give you 2. And that 2 that you get, you will add it with the original coefficient that's there. So 2, which will give you 4. Then that 4 goes up here and again multiplies by the number outside. So 4 times 2, which is 8. Then you add that to your original coefficient. So negative 11 plus 8. And you get negative 3. Then that negative 3 goes up here. And again, multiplies by the original coefficient, which is 2. So negative 3 times 2, which is negative 6. And that adds to the original coefficient, which is positive 6, to get 0. And then these are going to be the numbers that you have gotten. If you then get this last number to be 0, this tells you that there is no remainder. Okay? And the other 3 numbers that you have gotten will be your coefficients for your quotient. What do I mean by the quotient? Is when you're dividing long division, the number at the top. Yes? And obviously the coefficients subtract 1 from the start. So the first one will be x squared because the original number that you had to divide was in x cubed. So it will be 1x squared. and then plus 4x, and then minus 3. And that's going to be your quotient, the number at the top. Here the remainder is 0, which just means that if you take the original number, x cubed plus 2x minus 11x plus 6, and you divide it by your x minus 2, what you will get is x squared plus 4x minus 3. So next, let's do an example from scratch. So we have 2x cubed minus x plus 52. We're going to add our 0 term. So 2x cubed plus 0x squared minus x plus 52. And we have to divide it by x plus 3. First step you do is solve this and equate it to 0. So x plus 3 equals 0. We get x equals negative 3. And then we write down the coefficients. So 2, 0, negative 1, and 52. Draw our L shape and write our answer that we got outside. Then what we will do, bring the first number down as it is, so 2. Then that number you bring it up here and multiply it by the number outside the L. So 2 times negative 3, which is negative 6. Then that negative 6 you add it to the original coefficient. So 0 minus 6 will be negative 6. Then that negative 6 you take it back up here, multiplied by the number outside the L. You get negative 6 times negative 3, which is going to give you 18. And you add that with your original coefficient, which is negative 1. So negative 1 plus 18, you'll get 17. And then that 17 you take up here again, and you multiply by the number outside the L. So 17 times negative 3, you get negative 51. Plus 52, you'll get 1. And this right here is not a 0. And this is going to be your remainder at the end of it. So if you take your 2x cubed minus x plus 52 and you divide it by your x plus 3, what you will get is these coefficients for your quotient. And remember, the power goes down by 1. So it starts off with x squared, then it goes to x, then it goes to nothing, the constant term. So here if you divide, you'll get your answer as 2x squared minus 6x plus 17. And then you add that with your 1 remainder, obviously over your divisor that you had, as I explained earlier. That's how a remainder works. Next up, another example, and we're this time dividing 2x cubed minus 5x squared minus x plus 6 by 2x minus 3, right? And the first thing we would do is solve this divisor and equate it to 0. So 2x minus 3 equals 0. Take 3 to the other side. We get 2x equals 3. And then divide by 2 on both sides. We get x equals 3 over 2. Then that number goes outside of the L, remember. So we can draw our L with our coefficients in descending order of the powers of our variable. So 2, negative 5, negative 1, and positive 6. And outside the L, we have a 3 over 2. Then first thing is we take our first number down here 2, and we would bring it up here and multiply it with the number outside the L. So 2 times 3 over 2, which is going to be positive 3. Then we add that 3 to that negative 5. So negative 5 plus 3 is just going to be negative 2. Then we take that negative 2, take it back up, and multiply that again by 3 over 2. So negative 2 times 3 over 2. This time we get negative 3. And add that negative 3 to the original negative 1, and we get negative 4. And that negative 4, take it back up here and multiply it with the 3 over 2. So negative 4 times 3 over 2. And we get negative 6. Add that to the original 6 and we get 0, which is our remainder. So there is no remainder here. Now the difference here is slight because the divisor this time has a coefficient of more than 1, right? And this changes slightly for the synthetic division. Obviously the long division would stay the exact same. But the synthetic division, it changes slightly. What you do at the end is you divide by that coefficient, each of these coefficients. So you divide 2 by 2, divide negative 2 by 2, and divide negative 4 by 2. And here you will get 1, here you will get negative 1, and here you will get negative 2. And now these right here will be your coefficients for your quotient. The quotient being the answer that is on top of your long division sign, right? And again, you subtract one power from the highest power. So it starts off with x squared. then goes to x, then goes to nothing, the constant. This now means that if you take 2x cubed minus 5x squared minus x plus 6 and you divide it by 2x minus 3, you will get x squared minus x minus 2 as your answer. Next up, how do you divide a polynomial in order to find a factor? Now if you think of it, let's think of the number 6, right? What are the factors of 6? 1, 2, 3, and 6. We all know this, we've all been taught. But what exactly makes it a factor which doesn't make something like 4 a factor, right? And the whole thing is that these divide the original number without a remainder, while 4 will divide the original number with a remainder. So to make sure that x minus 3 is a factor of this, we need to make sure that x minus 3 divides this thing with no remainder. And so we're going to do that right now. We can use a long division again. So we have 2x cubed minus 5x squared minus x minus 6, and you know, divided by x minus 3. 2x cubed divided by x. X goes into 2x cubed how many times? 2x squared times. So 2x squared times x is just 2x cubed. And 2x squared times negative 3 is negative 6x squared. Then you'd subtract, and these cancel out. Negative 5x squared minus 6x squared. So you're adding your 6x squared. You end up with x squared. Then you bring down your negative x. And again, x goes into x squared how many times? X times. And then x times x is x squared. And x times negative 3 is negative 3x. Then you subtract again. These cancel out. Negative x minus 3x, which is just negative x plus 3x, which is just 2x. Then you bring down your negative 6. And then x goes into 2x 2 times. And then 2 times x is 2x. And 2 times negative 3 is negative 6. And you subtract and you get your remainder of 0. And what this shows you, that x minus 3 will divide this entire polynomial that we had initially, 2x cubed minus 5x squared minus x minus 6. And you get a remainder of 0 at the end, which shows that, yes, it is going to be a factor. Then remember, whenever you want to show for roots for a certain equation, you'll equate it to 0. But remember, this polynomial, you can now write it as x minus 3 times 2x squared plus x plus 2, the quotient. And you'll equate this to 0, which will give you that either x minus 3 is 0 or 2x squared plus x is 0. So we know that x minus 3 is 0, that means x can be 3. And we want to show that this is the only solution that's there. Only one real root. And for that, we need to show that this one does not have any solutions. And the way we can check that is from our pure 1 content, that b squared minus 4ac is less than 0, which will show that it has no real roots. So we can check that for this right here, where b is 1, so 1 squared minus 4 times a, which is 2, times c, which is 2 as well. And that will give me 1 minus 16, which is negative 15, which is certainly, yes, less than 0. And so this one will have no real roots. And therefore, the only root in this equation is x equals 3. The next example is for dividing a polynomial to find a remainder. We're going to use synthetic division for this. So firstly, we equate this to 0 and solve it. So x plus 3 equals 0. And x will equal negative 3. So that's going to be our number that's going to be outside our L. Then you write down your coefficients. Remember, this one does not have an x squared. So we're going to write 0 for that x squared. So we have 1, 0, negative 3, and 4. And outside the L, we have negative 3. Then we bring this number down and we write 1. Then we take that 1 here and multiply it by the negative 3. So 1 times negative 3, which is negative 3. Then add that to the 0 and we get negative 3. Then take that negative 3, bring it up, and that becomes negative 3. And you multiply it by the number outside, so negative 3 again. We get positive 9 here. Add that with the negative 3, we get 6. Then take the 6 up here again, multiply by the number outside the L, so 6 times negative 3, which is negative 18. And add that to 4, and we will get negative 14. And this right here is going to be our remainder for this division right here. Then next up we have the factor theorem, and this is not directly a topic that will be asked, but it's a good topic to know to strengthen your foundations in order to get better at answering your questions. So in the previous example, we had that x minus 2 was a factor of this right here. And what that means was, if we divide x cubed plus 2x squared minus 11x plus 6 by x minus 2, we will get the answer of x squared plus 4x minus 3, which we call the quotient. And that can also be written as you multiply these two together, as we said previously. Then we can say that if a polynomial px, we're just denoting it as px, like f of x, right, divides exactly, meaning without remainder, by a linear factor x minus c. So if this divides exactly by this to give this right here, which we call the quotient, that's why qx, then what we have is we can write them as a multiple of each other, as I've stated slightly earlier. And then if you equate it to 0, which I also did earlier, px equals to 0, which just gives you that x minus c qx equals to 0, which then gives us, as we know with the product of two items equating to 0, that we can either have the first one equaling 0 or the second one equaling 0, right? And with this we will have that x equals to c will be a value such that if you enter it in place of x for our polynomial, so if p of x, you write it as p of c, we will get 0 out of it. That means it will be a root of that polynomial. And so in general, if for a polynomial p of x, substituting c into the place of x gives you p of c equating to 0, that means x minus c will be a factor of p of x. A factor meaning something that divides p of x without a remainder. On the other hand, if again for a polynomial p of x, p of b over a, meaning if b over a is put in place of x, not c this time, now we have a fraction, then it will be slightly different, where we will take that a and multiply it with the x and then subtract b to it, and that will be our factor. The reason why this occurs is, remember, with x minus c we get x equals c because x minus c equals 0, and with this right here we get that x equals b over a, which gives us ax equals b, which gives us ax minus b equals 0. And so this is going to be a factor of p of x, because remember, as we write it, we have two products that multiply each other to get 0, and so either one of the product has to be 0, which is what this means. That means this is supposed to be one of the products, and this is the rewritten form of the original polynomial, where we use that as a divisor. Let's look at an example. Use the factor theorem to show that x minus 2 is a factor of this thing right here. The factor theorem says what? That if x minus c is a factor of a polynomial p of x, then if you substitute c into x, so pc, you will get back 0. And that's what they're doing. So they're equating that initial one to 0. We get x equals c. We put that c into the place of x. So in this case, the c is 2. And that 2, you put it in place of x. And what we get out of it is 0. And so p of 2 is equal to 0, which means yes, x minus 2 is a factor of this larger polynomial. Next, use the factor theorem to show that x minus 3 is a factor of this thing right here. So if this was a factor of this, then when we equate this to 0 and we get x equals to 3, if we put in 3 in place of x, we should get that this entire polynomial will equate to 0. That means if the function f of x is this right here, what we have, x power 3 plus 2x squared minus 16x plus 3, then if x minus 3 is a factor, f of 3 will equal to 0. Now we just have to check if this is true. So let's put 3 in place of x in all of them. So 3 cubed plus 2, 3 squared minus 16 times 3 plus 3. And that will give us 27 plus 18 minus 48 plus 3. 27 and 3 gives us 30. 30 plus 18 gives us 48. 48 minus 48 gives us 0, which is true. So f of 3 does give us 0, which means that x minus 3 is in fact a factor of x cubed plus 2x squared minus 16x plus 3 using the factor theorem. Next, we are given that 3x squared plus 5x minus 2 is a factor of this thing right here. We have to now find the value of a and the value of b. Now remember, if this is a factor of this polynomial, then equating this polynomial to 0 and putting the solutions of that equation into this, we should get that this polynomial equates to 0 as well, as per the factor theorem. So firstly, we need to solve what this is. So 3x squared plus 5x minus 2 equals 0. This right here can be factorized into 3x minus 1, x plus 2 equals 0, which then gives us 3x minus 1 equals 0 and x plus 2 equals 0, which gives us that x equals 1 over 3 and x equals negative 2. As per the factor theorem now, if we put any of these two x's into this polynomial, we should get that the polynomial equating to 0. That means 3 1 over 3 cubed plus 17 1 over 3 squared plus a 1 over 3 plus b should equal to 0. And also 3 times negative 2 cubed plus 17 times negative 2 squared plus a times negative 2 plus b should also equal to 0. The first one right here is going to be 1 over 9 plus 17 over 9 plus a over 3 plus b equals 0. This right here is going to be 2, so 2 plus a over 3 plus b equals 0, which means a over 3 plus b equals negative 2. And just to make this simpler, not necessary, but we get that a plus 3b equals negative 6 after we multiply the entire thing by 3 to remove the denominator. So this is our first equation that we get out of it. The second one, using this, we get that negative 24 plus 68 minus 2a plus b equals 0. So we end up getting negative 2a plus b equals negative 44 if you rewrite it. So this is our second equation, negative 2a plus b equals negative 44. And solving this simultaneously, we already know how to do this. We will get that a equals to 18 and b equals to negative 8. And now what you can do to confirm is check. So do this on your own, but check that 3x cubed plus 17x squared plus 18x minus 8. If you put in your 1 over 3 and negative 2, do you in fact get this equating to 0 or not? And if yes, then we have found the correct values of a and b. For the second part, we need to factorize a polynomial completely. So we can use long division here, where we have 3x cubed plus 17x squared plus ax, where a is 18, so plus 18x, plus b, which is negative 8, so minus 8. And we divide this by 3x squared plus 5x minus 2. Then do it the same way. Then we do this the same way, where 3x squared goes into 3x cubed x times. Then we do x times 3x squared, which is 3x cubed, x times 5x, which is 5x squared, and x times negative 2, which is negative 2x. Then we subtract this, and this cancel out. 17x squared minus 5x squared is just 12x squared, and 18x minus 2x is just going to be 20x. Then we bring down the negative 8 as well and do that again. So 3x squared goes into 12x squared 4 times, so we have plus 4. Then 4 times 3x squared is 12x squared, 4 times 5x is 20x, and 4 times negative 2 is negative 8. Then we can subtract these to find our remainder, and we get that our remainder is 0. That means factorizing the polynomial completely, we currently have x plus 4, 3x squared plus 5x minus 2, and that is equal to that 3x cubed plus 17x squared plus 18x minus 8. But remember, we haven't yet factorized it completely, because remember, we could factorize this as well, and we did that when we found our answers for a, and we got for this was 3x minus 1 and x plus 2. So we can rewrite this again, where x plus 4, 3x minus 1, and x plus 2 gives us this polynomial right here. That means this is the completed factorizing form of this polynomial right here. Next example, you want to use the factor theorem to determine a factor. That means you want to find a solution to this equation and get a factor from that to get all the other solutions that we have. So for this, whenever we have a third degree polynomial, which means x cubed is the largest degree of the variable, then to find a solution we need to use trial and error. So we take the last constant here, 14, and write the factors of this, positive and negative. So we have positive and negative 1, positive and negative 2, positive and negative 7, and positive and negative 14. Then we try each of these, put them in place of x, and see if they equate to 0. Because remember, as per the factor theorem, if they do equate to 0, then that solution can in fact be rewritten as a factor of this polynomial. And we can start off by putting 1, positive 1 into this. So 1 cubed plus 4 1 squared minus 19 1 plus 14 equals 0. Here we get 1 plus 4 minus 19 plus 14, and that gives us 5 plus 14, which is 19, minus 19, which is 0. So that immediately gets us a solution where x equals to 1 is our solution. To reverse engineer a factor out of it, you just take it to the other side and we have x minus 1 equals 0. You should now know that this is going to be a factor of that polynomial as we have done previously. Then once we get this as a factor, we can use this to get all the other factors. How? We can divide this polynomial by this factor. Let's use synthetic division this time. So we have 1 on the left, then we have 1, 4, negative 19, and 14. We bring down the 1, we bring it up, 1 times 1, the number outside, we get 1, and then we add that to the 4, we get 5. Take that 5 up, 5 times 1, the number outside, we get 5, plus the negative 19, we get negative 14. Take the negative 14 up here, negative 14 times 1, we get negative 14, plus the original 14 we get is 0. So our remainder is 0, and these are our coefficients for our quotient. The variables, the degree will reduce by 1. So this will be x squared, this will be x, and this will be your constant. Obviously adding and you're subtracting. So we end up getting x minus 1, x squared plus 5x minus 14 is equal to the polynomial right there. So x cubed plus 4x squared minus 19x plus 14. And with that, we can get our solutions for this. So we obviously have that this right here, we want to equate it to 0. Which means x minus 1 equals to 0, which just gives us x equals 1. And we can solve this as well, this quadratic equation, where x squared plus 5x minus 14 equals 0. We can factorize this to get x plus 7 and x minus 2 equals 0, which gives us two answers, which is x equals negative 7 and x equals positive 2. So we end up getting three solutions, in fact, for this polynomial. The first one being x equals 1. Second one, x equals 2, and the third one, x equals negative 7. So we looked at the factor theorem, and that was to find if something was a factor. The remainder theorem, on the other hand, quite similar to factor theorem, just that instead we get what the remainder is. Okay, so for example, consider this polynomial right here, 2x cubed minus 5x squared minus 2x plus 12. If you substitute x equals to 2 into this, so 2 times 2 cubed minus 5 times 2 squared minus 2 times 2 plus 12, we get the answer 4, right? And if you divide it by x minus 2, that same polynomial, x minus 2 we get from where? The fact that x equals to 2, and you get that x minus 2 equals 0. If we divide it by x minus 2, the normal long division way, we get a remainder, which was the same answer we got when we put 2 into the original polynomial, which is 4. And this means that the function, which is this polynomial right here, can now be written as x minus 2, which is the divisor, multiplied by the quotient, which is 2x squared minus x minus 4, and you have your remainder plus 4. So in general, if a polynomial p of x, again, we're just writing general p of x for a polynomial, is divided by x minus c, then the remainder, obviously if it exists, the remainder is going to be the answer you get when you put that c into the polynomial. So is p of c. On the other hand, obviously, when you divide it by ax minus b, so p of x over ax minus b, then the remainder here would be p of b over a, as we did earlier, right, with the b over a and ax minus b. So that's what the remainder theorem is. Quite similar to the factor theorem, just a slight difference of there existing a remainder instead of it being a pure factor. We have two examples here. Find the remainder when 4x cubed minus 2x squared plus 5x minus 8 is divided by x plus 1, obviously using the remainder theorem. The way we get this is we equate this to 0 and solve it. So x plus 1 equals 0, we get x equals negative 1. And if we put that negative 1 into the polynomial, the answer we'll get out of that will be our remainder. So let's put the negative 1 into this. So 4 negative 1 cubed minus 2 negative 1 squared plus 5 negative 1 minus 8. And here we get 4 times negative 1, which is negative 4. Negative 2 times 1, which is negative 2. 5 times negative 1, which is negative 5. And then you have minus 8 at the end. And this gives us negative 19. That means this right here will be our remainder when 4x cubed minus 2x squared plus 5x minus 8 is divided by x plus 1. Next up, we get 6x cubed plus ax squared plus bx minus 4 is divided by x minus 1. When it is divided by that x minus 1, we get the remainder as 3. Which means when we put x equals to 1 into this polynomial, so 6 1 cubed plus a 1 squared plus b 1 minus 4, our remainder will be 3. That means we will get 3 as our answer. The reason I chose x minus 1 is because we equate this to 0 and solve that. So x minus 1 equals 0, which gives us x equals 1. Next, when f of x is divided by 3x plus 2, the remainder is negative 2. So again, we solve this after equating it to 0. So 3x minus 2 equals 0, which is just x equals 2 over 3. Then that 2 over 3, if we put it into the polynomial, we will get negative 2. So 6, 2 over 3 cubed plus a, 2 over 3 squared plus b, 2 over 3 minus 4. And what we get here is negative 2, because that was our remainder when we divided by 3x plus 2. With this, again, we will get two simultaneous equations. The first one being a plus b equals 1. And the second one being 4 over 9a plus 2 over 3b equals 2 over 9. Rewriting this will give us 4a plus 6b equals 2 after we multiply the whole thing by 9. Then we can solve these two simultaneously and we get that a equals 2 and b equals negative 1. And that gives us the value of a and b.